Okay, so we're going to have a look at a number question from the 2012 Leaving Cert Ordinary Level Paper 1. So the question gives us a value for a, root 2, and then it asks us whether each of these 5 expressions in terms of a is a rational or an irrational number. So first of all, to give definitions for rational and irrational numbers. Well, a rational number, also known as a fraction or a decimal that can be written as a fraction, they're numbers that can be written a over b, where a and b are integers and b can't be 0. So obviously you're not allowed to divide by 0 in maths, that's undefined, and so b obviously can't be 0, but where a and b are any other integers. To give a few examples before we start, a number like 7 over 2, that's a rational number. It's a fraction, a over b, and 7 and 2 are both integers. A number like 3, that would be a rational number because 3 can be expressed as 3 over 1, which is a fraction, a over b, where a and b are both integers. A decimal such as 0.432 can be written as a fraction, 432 over 1,000, and so that's a rational number. So what are irrational numbers then? Well, irrational numbers then are any other real numbers that cannot be written as fractions. So the notation here, r without q, means the real numbers without any of the rational numbers, the numbers that can be written as fractions. So examples of irrational numbers would be root 2, pi, e. These are numbers that can't be written as fractions. These are numbers that have never-ending decimals. So we can see in our question that a itself, root 2 is an irrational number. Now how we're going to calculate these is we're going to substitute a in for each one, and then we'll see if it's a rational number or an irrational number. So remember that a is root 2, and so the first one here is just a. A is the number root 2. Root 2 is a never-ending decimal. It can't be written as a fraction, a over b, where a and b are integers, and so we say that it's an irrational number. A minus 1, well, a minus 1 is root 2 minus 1, and if you subtract 1 from an irrational number, you're still going to have an irrational number. Minus a squared is going to be minus root 2 squared. Now when we square a surd, we get the number underneath that surd. So minus by minus is a plus, and root 2 by root 2 is 2. And so we get a real number. And as we said before, 2 can be written as 2 over 1, which is a rational number. It's a fraction, a over b, where a and b are both integers. A minus 2 squared, well, we'd have to sub in root 2 minus 2, square that. If we were to actually open the brackets and multiply it out, we'd see that that's 6 minus 4 root 2, which is a never-ending decimal. It's still an irrational number. Finally, 1 plus a squared, well, that'll be 1 plus root 2 squared. Root 2 squared is just 2, so that will be 1 plus 2, which is the number 3. And as we stated already, 3 is a rational number. It can be written as 3 over 1, where both 3 and 1 are integers. The B part of the question then asks us to show the following numbers on the number line below. So a, minus a, root a, and a to the power of minus 2. Now remember, a is still the number root 2. So to see where exactly they lie on the number line, we're going to change them into decimals so that we can compare them and accurately place them on the number line. So a is root 2, so to place root 2, we're going to change root 2 into its decimal, which is 1.41421. Remember that that decimal goes on forever. Our number line is only split into tenths. So if we start at 1, we have 1, 1.1, 1.2, 1.3, 1.4, and so it's just a little bit after 1.4, so we'll place it there. Minus a is equal to minus root 2, which is equal to minus 1.41421. So again, going from the other side, and we go down in tenths, we have minus 1.1, 0.2, 0.3, 0.4, and so minus 1.41 is just a little after the minus 1. The root of a is the root of 2, and the root of 2 is equal to 1.18920. So that's going to be pretty close to 1.2. So we have 1, 1.1, 1.2, and so it's a little before 1.2. The final one, a to the power of minus 2, well, that's equal to root 2 to the power of minus 2, which is equal to a half. And a half is halfway between 0 and 1, so we're just going to place it right here. Without using the calculator to show that that was a half, we could have said that a to the minus 2, using the rules of indices, is equal to 1 over a squared. That would have been 1 over root 2 squared, which is 1 over 2. And 1 over 2 is equivalent to 0.5.